So yeah. So once again, hope you all are doing well. So guys, welcome to our reputed VLSI training and placement program demo session. We are very much delighted to have each and every one of you here today as we embark on a journey of learning and growth. Okay, so basically, we are going to start our DFT training and placement program from probably this 20th or 21st of April. So before that, we would like to introduce or interact you people to our industry experts, so that what are the queries you have regarding the VLSI industry and how we can start a career in booming in VLSI industry. And we'll share the curriculum as well. What would be the curriculum of our DFT training, and more inputs like how our training will go, and what are the tools we'll work it out, and how the placement support will be there. Everything will be shared here, and you can share your what are the, if you have any queries related to technical, non-technical placement part, we can discuss over here. So these demo sessions serve as a platform for you to experience the unique blend of expertise and innovation that our training and placement program offers. Okay, so once again, welcome to the training demo session. We are thrilled to have you here and look forward to productive and enlightening session. So guys, I want everyone to be very much proactive, and please, if you have any queries in between, please make a note of the queries and questions. Okay, so end of the Q&A session, we can have those questions to be answered. But I wanted this session to be very much interactive. Okay. So I'll just take you through the success bridge for like less than 10 minutes. Then we'll hand the session to the trainer. Hope my screen visible to everyone.
Yes.
Yeah. So guys, so welcome to Success Bridge. So about Success Bridge, Success Bridge was founded and managed with the industry experts who have more than a decade experience in the industry. Okay. So Success Bridge is industry aligned training company, offers the best VLSI and software placement program. So in we basically offer VLSI as well as the software. In software, we basically focus more on the cloud infrastructure trainings. Okay, so this is our website, www.successbridge.co.in. So it's our Success Bridge vision. So we wanted to be a recognized leader in the industry, basically by providing the knowledge, skills, and confidence to empower the individuals with the transformative learning experience. So that prepares every individual to get success in rapidly changing world. You know how rapidly the current world is changing. So where the change is always required. So we would like to help each every individual with our training process. So to reach our vision, what vision we have opted is we would like to provide high quality, user-friendly training services that enhance the productivity of every individual, that will profit for an individual and as well as an organization. So these are trainings. So in VLSI, we basically provide design verification, front end, DFT, physical design, analog layout, and cloud. In software, we'll provide cloud infrastructure trainings. These are our basically curriculums of design verification. As I told you, I don't take you much time with this thing because we have our important more content like ahead of us. So design verification will cover digital design system, this introduction to HDL, VHDL, advanced Verilog concepts, advanced system Verilog concepts, UVM, and direct random testing and functional coverage closure. Yeah, this is a DFT which we are going to start our batch. So in DFT, we basically cover along with the basics. So we'll start with the basics of a digital logic design. So whatever is required to start a DFT engineer, so we'll start with the basics of digital logic design, and then we'll move out to introduction to DFT, full ASIC flow, or DFT, boundary scan, understanding of scan in depth, JTAG operations, ATPG and simulations, basics of L-Bist and M-Bist, which are the basic, now currently the advanced topics, basics of scripting language as well. So these are PD curriculum, where we will look into their interaction of PD, STA, floor plan, power plan, placement, CTS, which is like in basically GDS to this one, PNR. Okay, then this is the analog layout. Then a cloud infrastructure. Here in cloud infrastructure, we basically cover hardware networking, Windows administration, Linux administration, VMware, Amazon Web Services, Microsoft Azure, and ITL and soft skills. Okay, so along with the technical part, we basically look into the soft skills as well, which is very much required, because being a technical, if you are good in technical, but if you are not able to make understand your interviewer what exactly you are good in technical, so it's like an waste of your efforts. So we basically work on the soft skills as well, which will help us the communication skills, personality development, presentation skills. Every weekly or monthly we'll have 1 or 2 sessions of presentation skills, either individually or group. So this will help individual for the coming out of the stage fear and all, public speaking and email writing and etiquette, interview skills, and much more. Okay, so this is our selection process. So whoever is interested, they have to apply on the website. Then or any of our counselors will call them, connect with them. Then we'll have the application screening. Online, offline assessments would be there, and technical HR discussion, the admission. So these are our specifications. So I just wanted to let you know what is some couple of things which is unique with compared to other institutions. There, I wanted to say highly like in basically 3 to 4 things. The first one is the trainer. The trainers with whom we are empaneled, they are the employees of product-based companies. Now the DFT trainer who is going to take up the session, he has more than like a decade of experience in the DFT domain itself. Okay, and we basically work on the industry standard oriented tools. So we are going to work with the synopsis tools for DFT, PD, and the DV as well. So real-time projects will be there, and module-wise assignments. So after completion of each and every module, you'll have the assignments as well. Okay, and as I told you, right, we'll work with the soft skills and communication sessions also. So, and one more thing, if you go to other institutions, the maximum, they'll go with the maximum count of 60, 80, much more than that. But here, the maximum count would be either 15, not more than 20. Okay, and we already done with like in 10 to 12 registrations. So we have very less registrations available. So after this demo, I wanted everyone to complete the registrations. Okay, so mock interviews, after, as I told you, right, we'll have the mock interviews either before completion of your training. 1 or 2 mock interviews will be planned, which will be taken care by our industry experts. Okay, so these mock interviews help each and every individual to understand what is the market requirement, how you need to answer the questions, what do the technical questions will be expected. This will helpful for the mock interviews. So individual focus and flexible timings. Okay, so since we have less than 15 students, so it will be very much helpful for us to go the individual focus and flexible timings. So classes will have every day 7 to 9 sessions, 7 to 9 p.m. So these are the pure live sessions, not the pre-recorded. These are the pure live sessions, not the pre-recorded. If you go to other institutions, they basically run their pre-recorded sessions, and weekly once or twice they'll have the doubt clarification session. But here, no. So we'll have the live sessions, and these sessions will be recorded, and we will give the recording access to you. For example, if you miss out any 1 or 2 sessions, you can go through those weekly recording sessions, so you can cover the topics. Okay, but we would suggest, advise everyone to be available for each and every session. Okay, yeah. So affordable fee. So basically, guys, our trainings for offline will go with the 1 lakh plus GST. For online, our charges are 80,000. But now, since we are empaneled with Make in India process, so now this time we are going to offer a online training for 65K. Okay, and that can be paid in couple of installments, as I told you, right? So actually it was 80K. Now we are going to offer for this batch, the fee is 65K, and 10K as you have to pay as a registration fee. The remaining can be paid in couple of installments. So as I told you guys, so maximum count of a batch will be 15. I think we almost got 10 to 12 registration. So very less seats are available. So once after the demo, we can go to registration. Yeah. The next, last but not least, 100% placement support till everyone get placed. So we have people who have got placed immediately on or before the completion of training, and we there will be, see, there are many things which is engaged with the placements. Sometimes the market condition, sometimes I can say the client requirement. So we may have, sometimes placements will happen immediately, sometimes it may delayed for a month, 2 3 also. So but till everyone get placed, we are there to help you with the placements. Since, as we told you, right, we have the trainer as an industry expert, and we will be using the industry standard tools, and maximum head count of 15 students per batch. So obviously, we don't have any concern. We can happily place each and everyone. But again, when I say 100%, for example, 50% from success grid, 50% from Mr. X. But what Mr. X should be done, that will be educated and thought by the success based team. Yeah. So guys, so EDA, so our partners basically, so we have empaneled with Synopsys for our EDA tools, and coming to the placement partner, actually we have not updated here. So we have our own service company by name N-Semi Design Services India Private Limited. So which will come as an placement partner for you guys. So if you wanted, you can look it out at www.nsemidesign.com. So this is our VLSI service company. So if you are really good, if you can prove yourself in the technical perspective, so we are there to hire you in order to look at any external opportunities. Okay. So along with this, our people are got placed, and since still we have got yet to receive into update from the in semi HCL and all. So these is our contact details. If wanted, you can reach out through email by info@successbeat.co.in. Our website successbeat.co.in. Our contact numbers are mentioned here. Now we currently located in Koramangala 4th block. Okay. Yeah. So I think we have our okay. So before we move out to the before we move out to the technical session, so I would request Mr. Om, or recently placed one of our previous current batch student. I would like to inform him to share his experience, how was the training and all.
Uh, Hi everyone, thank you sir giving the opportunity for explaining myself. So I would like to tell everybody first of all what about the training, how the people are miss our trainer and all the success paid institute people are supporting us. So training was whatever the curriculum schedules, it was good and it is useful for the further assignment and labs in the and as well as the industrial industrial level projects. So whatever our the trainers and miss whatever a trainer will teach, it will be helpful for them writing the assignments as well as performing the labs. In mostly we use the synopsis for the DFT, scan insertion process and all. You know that curriculum, it will helpful for the scan insertion, that synopsis tool. So in that we can see what our trainer is teaching. Upon that we need to perform the labs, and it is helpful by using these tools. And for the different one more the module, it we have the DFT max tools. In that we have we are going for the pattern generation. All that is some of the topics. So we need to go for the DFT engineers. So it is very useful. Trainer also very useful. They are also supportive natures. And mostly whatever we have the problems, you can think in the groups also. They will make the groups for the students. And if you have still doubt, so you can ping the individual also. Our trainer is also good. He will help at any point of means. Whenever they are free, they will ping us what is the problem, and we have the access for the tool, so we can perform the labs. Apart from this, the having the placements also in the placements, they will support really good. And one more thing, up to your chance, means our side also we need to prepare, that is also our side, because they will give the placement support, but our means we need to in the platform, they will provide one platform, we need to do really hard work, so we can get the place as soon as possible. They will support as up to placement. So they will give some different types of means model wise training, so it will help. First they will teach us some models, upon that they will assign the means they will give the assignment, so it is useful for the real-time industrial projects. And we have the access of that synopsis tools and the optimize tools. So on the real time, we can see the what is the problem when we are performing the projects where we perform the labs. If any doubt, if any error, we can let him to know how to debug, how to. Our trainer will help us. And thank you so much. I'm damn sure one thing, it will be a benefit for the futures if you are really thinking the DFT engineers. The growth is also in the real time market. Market is also growing like anything. Means it is at the top of the scene. So semiconductor industry, you guys also knows what is the current situation. So I'm suggested, if you are really interested, try to get in and uh, build ourselves and get it the better opportunity from the success rate. Thank you so much, sir.
Thank you, Om. Thanks for your time. So,
Yes, sir,
guys,
thank you.
yeah. So actually, Om has started his career. We have started a new batch in month of October. So they have completed their training in mid of Feb and March. And recently, he and one of his batchmate got placed in advanced logics. And also, we have got one more placement in SOC team up. And couple of more interview updates are awaited. We have people are attending in Semi and HCL and other companies as well. So as we told it, we are there to provide opportunities. It's again, it's your responsibility how you are going to utilize it. Okay. Yeah. So now we will move out to this technical part. So as I told you, right, I would like to introduce our trainer, Mr. Ahmed, who is going to take care of the current DFT batch, and he's also the trainer of the previous batch where Om has attended the training. So Mr. Ahmed has approx 12 years of experience in DFT. Okay. So hopefully his experience is going to help us to help us success bridge to like and brighten our name and to help each and every one of the DFT engineers who wanted to start their career. So hi Ahmed.
Hello. Hi, Shaikh. Good morning.
Yeah, Ahmed. So please go ahead with the session. Okay.
Okay,
So,
sure. Hi, everyone.
right, please, I wanted everyone to be very much active. So if you have any queries, please make a note of those. During the Q&A session, we will have the connection. We will have the answers. The questions will be answered. So your one question is going to help others also to get more information about their career and all. Okay. Yeah. Thank you, Ahmed. Please go ahead.
Okay. Hi, everyone, and welcome to the demo class for the DFT. So I hope everyone can hear me properly. My voice is loud and clear. Is it?
Yes, Ahmed.
Okay. Okay. Thank you. Let me quickly share my screen. Let me know if you can see my screen already. Is it visible to everyone? My screen?
Yes, Ahmed.
Okay.
No,
Okay.
sir.
Sorry? Somebody say no.
Yeah, sir, your screen is not visible to me.
Okay.
How about the others?
I can see your screen.
Okay, that's good. Yeah, I see a lot of people is responding that they are able to see my screen. Maybe uh, those who are still facing some issue, maybe you can just drop and then reconnect. Then it will be able to.
Connectivity issue.
Yeah,
Yeah,
maybe
sir.
the
Now,
connectivity.
now it is visible. Now it is.
Okay. Thank you.
Okay. Okay. Thank you. Okay. Hi everyone. Welcome to our demo class. And this is where we are going to discuss about the DFT, which is actually means the design for testability. This is one of the important domain in the IC design phase, and I will be trying to give a quick overview how this DFT is doing into the industry and what is the future career that you have if you choose to go through this path. So I'll discuss some of the overview and all the technical details, give you a short overview on this. So these are the few topics that I will be going to cover here in my discussion. So introduction of the trainer, and then a basic overview of the IC design flow, and then the DFT flow, and the EDA tool, electronic design automation tool, and what are the tool we are going to use for the DFT, and scan insertion principle, and then moving forward, semiconductor industry overview, how the semiconductor industry and what are the companies that now doing different type of activities and where we are actually playing our roles. So I'll give some overview on that, and we'll give you a short overview on how is the career opportunity for the DFT engineers. And finally, we'll give you some of the training program that we have right now. We'll give you the update on the contents that we are going to plan for the training purpose. So introduction to the trainer, I think Shaikh has already given me some brief overview. I have around a decade of experience into this industry, and I have already worked in multiple projects from the design phase to the post-silicon and manufacturing phase, and then deliver the product to the customer. So the DFT is actually included both into the design phase, and also it covers some of the activity into the post-design. That means post-manufacturing, where the chip coming from the fabrication, you have to test it, make sure the chip is very good, and until we deliver it to the customer. So in all those phases, you have some kind of engagement as a DFT engineer. And for my case, actually, I have worked in all the different phases that the DFT engineer need to be engaged for a final product need to be handed over to the customers. So let me quickly jump to the design steps for the IC. So this is the short information or summarized information where actually we can see how a IC is planned to design. So there are multiple phases where multiple engineers are engaged to complete all the requirements. So if I briefly talk about this, so any kind of chip, it starts with the system specification. That means it's the phase of architecture overview. Let's say Intel is trying to develop a new processor. So the first phase it will come that they will plan how the architecture should be. On all those specification is based on the customer request because they have to sell the product to the customer. So the customer will give them some specification. Based on that specification, the Intel DFT, not DFT, is the Intel architect who has experience around 30 years, 40 years. They will build the architectural specification to meet the customer specification. So after the specification or architecture design is complete, then it will be going for the functional verification team because they have to make sure the design met the customer specification. In order to make that successful, the functional verification engineer will have that kind of checking. So that kind of activity, the architecture design and functional design, this is what we call as a front end. There are few technical term or few industry term you will be familiar with this. one of the term is the front-end engineer. The front-end engineers are mainly who are actually involved into the architectural design and functional verification. So once the design has already been functionally verified, then the design goes to the back-end engineer. Back-end engineers mainly involve a lot of team. One of the major team is the physical design team. You see, the name is the physical design. So basically, the physical design team takes the RTL or the design file. The design file we call is as a RTL file, register transfer level. It's a Verilog code, some kind of coding. But you have to transfer it to the gate level. You see the gate. This is some logical gate. So from the RTL level, it need to be transferred to the gate level, and those engineer, they do this kind of activity. They are called the physical design engineer, and this is where they called as a back-end engineer, front-end, back-end. So our DFT team is also closely work with the physical design team as well. Physical design team is usually a big team, and they have a lot of steps to perform to complete their physical design. And one of the steps is the DFT insertion and all those things. So as a DFT engineer, you will be called as a back-end engineer. You will be closely working with the physical design team. And sometimes you can also interact with the functional verification team or the RTL design team. It depends based on the design requirement. But most of the time, we have to work with the physical design team. So this is where the DFT team start to play their role to make sure the physical design and DFT insertion into the gate level netlist is successful, and they can complete all the verification before they start to the tape in. This is, you see, the tape in, tape out. These are the few technical terms you will heard frequently. So tape in, tape out means the design. This is the design phase where all the design check has been done, and the design has made all kind of functionality check. That is why they call it a physical verification and sign off. So when you are into this stage, from here to here, we call this as a pre-silicon design, because the silicon is not there yet. It is a pre-silicon design. So in the pre-silicon design, you have the architect, you have the functional verification engineer, which are the front end. Then it will go to the back-end engineer, where the physical design will be there, where the DFT engineer will be there, and everything, once it is complete, we call as a sign-off pre-silicon design, which is we call as a tape-in, or sometimes called as a tape-out. Both are equivalent. So after you done the tape-out of the design, it will go for fabrication process. It will go to the foundry. Those have the technology, they can do the manufacturing of your device. That is called the fabrication. So now you think that until this step, you have done all kind of checks and everything is clean. All the netlist is clean, everything is passed, no problem. But when the design goes into the fabrication process is a physical process. So in that process, there could be some kind of problem. It can happen because no process is 100% error free. So when the design goes to the fabrication process, actually there could be some kind of defect can be introduced there. Because in manufacturing process, let's say you have a power rail voltage. Due to some kind of manufacturing defect, the voltage rail is shorted to the ground. Because the physical IC, you see, this is the physical IC. This net can be short to this net. It can happen. In pre-silicon, it will not happen because pre-silicon is a design phase. It will not happen. But during the fabrication manufacturing process, it can happen. And that is where we call as a defect can be introduced in this fabrication process. Even after the chip has been fabricated, when it goes for packaging, during that phase, the defect can also be introduced. So as a DFT engineer, this is where you have to play the role. So during the manufacturing process, if there is any kind of defect introduced, how can we screen out those defective parts so that we can make sure a very good part delivered to the customer? That's the role of a DFT engineer we have to play. So I hope I can give you some of understanding that in the full IC design phase, where the DFT engineer play their role and how they are contributing to manufacturing a very good product to the customer. You see, this is a very important, right? Because if the product we are purchasing from the client, let's say you are purchasing an iPhone. Usually the iPhone is very good. Everybody uses, no claim that the product is running very fast because they have tested it very good. Their DFT architecture is very good. That's why they have make sure that this is a very defect-free product. That's why the client or the end customer, they are happy with this product. So this is where our role, we have to be very careful on that because the product quality will be dependent on the DFT engineers. Okay, let's move on to a more detail. As I just mentioned that in the full IC design, where you are playing the role as a DFT engineer. Now, I will give some more detail on how the DFT flow actually goes and what are the activities we have to perform for a proper DFT insertion in our design. So if you consider this is the full chip, this chip will have some kind of input and it will have some output. And inside the chip, there will be some combinational logic. Combinational logic, they call is a, like we have some digital logic gate, right? AND gate, OR gate, marks. These are called digital logic gate. And we have a special gate, logic gate, that is what we call as a flip-flop, which is a memory element. So basically the digital chip will have two types of component. One is the combinational logic, AND gate, OR gate, and another one is the sequential device, which is called as a flip-flop. So when we take this kind of design, as we call, this is the initial design phase, right? After completing the functional verification, it will come to the DFT engineer to insert the DFT logic, design for testability logic. So what we have to do is that, basically, you see the input and output of the device. It is connected to the internal logic and it will also be connected to the board as well. Because in a motherboard, there will be multiple chips, right? One chip will interact with another chip. So we have to make sure we should put some kind of logic at the boundary to make sure we can test all the input and output are functioning properly. They can communicate with the other chip properly. We have to make sure that kind of scenario. That is what we call, we have to put a boundary scan logic around the chip. This is what you see. Insert and verify boundary scan logic. This is one of our important phase as a DFT engineer to make sure all our boundary is working properly. And then if we can verify all the boundaries working fine, then we have to verify that our internal logic, they are also defect free. We have to put some kind of internal logic, DFT logic, to make sure the logic can be tested properly. That is what we put it here. Insert internal scan circuitry. This is the another phase. The synthesis and optimize, this is usually done by the physical design engineer. Most of the time they do this. We DFT engineer don't do this. That verify timing, this is also be done by the physical design engineer. But we do the scan insertion once the netlist is coming prepared by the synthesis process. This stage is to verify all the internal logic has been manufactured properly. There is no fault. So after we complete the boundary scan verification, internal logic verification, or internal logic DFT, we have to generate the patterns. You see, actually, ultimately, the objective of the DFT is to make sure we can generate some kind of test vector so that we can apply this in the tester ATE after manufacturing process to test the internal logic. So DFT have two parts. One is the DFT scan insertion Another one is the ATPG pattern generation, the pattern that will be used for the tester to verify all the manufacturing process. So this is another step, verify and generate ATPG patterns. These are the, these are all 0, 1, 0, 1, this kind of vector that we have to generate. So after you do the scan insertion, complete all the verification, generate the ATPG pattern, you will hand off this to the vendor. Vendor means it's a post-silicon engineer. Those who will be working on the ATE tester, they will pick up your pattern and then they will develop some kind of test to drive that pattern from the ATE to the manufacturing chip to make sure your chip is working fine. So in this whole flow, you have three places to play your role. One is the scan insertion, where you see the built-in test or boundary scan. These are part of the DFT role. Scan insertion, internal scan, it is also part of the DFT role. Verify pattern, generate pattern, part of the DFT role. And hand off to the test engineer. So test engineer also need to have the experience of the DFT as well. So as a DFT engineer, you also need to be closely working with the test engineer to make sure your pattern, whatever you have delivered, it is actually passing. As long as it is not passing, then there is no benefit of the pattern. So you have to closely work with the test engineer as well. So you now know that how much role you have to play during the entire design flow and how you are actually contributing to the industry. Okay, now let me talk about few words about the industry investor tool. So during this DFT process, actually we use some kind of EDA tools to help us insert the DFT logic, do the DFT verification, and then generate the ATPG pattern. So everything, we don't do any kind of manual work because the process is highly automated. We have to operate the tool properly based on our knowledge so that we can achieve our goal. So these are the three important tools that is very popular into the industry for any kind of DFT. The first one is the Siemens Station tool. This is the industry leading tool. Most of the around majority of the company, they prefer to use the Siemens EDA tool. It is a very good architecture, EDT architecture, OCC, scan ATPG. So all those things is very popular. But another important tool is coming from the Synopsys. Synopsys is also very competing with the Siemens Station tool. So in many of the design or many of the companies also prefer the Synopsys tool. And also in our training session, we will have multiple labs where we will be using the Synopsys TestMax tool. This is also very good. But another big company is the Cadence. Cadence has also a tool they call as a Modus test solution. This is also a very good, but it's not that much popular. But now it is getting more popularity because it's a bit cheaper compared to the other tools. So now many of the companies thinking, okay, let's try to use the Cadence tool to optimize our budget because it can give the same performance. So now many companies trying to look for alternate to use the Cadence tool. But in our training session, we'll be using the Synopsys tool. Okay, now I want to give a brief technical depth that what the DFT engineer actually need to be do. Because as a DFT engineer, you have to understand your role first, that what you want to achieve. Then only you can think of, okay, this is something is look interesting for me, so I should choose this career path. So as I already mentioned, that during the chip design process, when it goes to the manufacturing process, in the manufacturing process, due to some kind of variation, the defect can be introduced. The defect means, let's say this is the 2 net. So somehow during the manufacturing process, there is a dust here. And in this dust, that will cause the 2 net to be shorted. So this kind of scenario we call as a manufacturing defect. But as a DFT engineer, you have to develop something in your design to make sure you can detect this kind of defect. That's why we start to do the modeling of the defect into the pre-silicon phase, because DFT engineer is working into the pre-silicon, right? Into the gate level netlist. But you have to make sure you can model it properly. So when the design go into the manufacturing process, what it will happen, you can automatically know into the pre-silicon phase and take necessary steps to detect that. That is what we call, this is the manufacturing process defect has been introduced. We do it as a fault modeling. This is what we do, the fault modeling. Okay, this is net is short. That means if it is a gate, one of the leg of the gate may be connected to the ground. That is where I do the modeling. And if this happen, can I generate any test pattern to detect this kind of fault? That is what we call as a pattern generation. So ultimately, defect will happen into the manufacturing process. It will create some fault into your design, which will cause some kind of error, and ultimately your device will do malfunctioning. Now, these are the few areas where most probably the defect can happen into the whole process of IC packaging or IC manufacturing. Like when the IC started to manufacturing, it comes with the silicon, right? Silicon, they do the processing to make it as a chip. So during that processing, the impurities can be introduced, which can cause a defect. So that is what we call as a surface impurities bulk defect. But when the wafer fabrication starts, during the wafer fabrication, there will be a lot of steps one by one, like dust particle, mask problem, lithography problem. There are multiple steps. In every step, there could be some kind of issue or error. It will introduce some kind of defect into your design. Open short, gate offside short, transistor VT short. These are the few possible scenarios. We'll have more discussion during our training session on how this can happen. So this is just a one-page slide to give you an overview. So during the packaging, the problem can also happen. The defect can also be introduced. So now you already know that the problem that the DFT engineer has to handle is to identify the manufacturing defect. Or after fabrication, what can happen, we have to handle it earlier. So that's why we actually develop a lot of fault modeling. The way the fault can happen during the manufacturing process, we do the modeling it into the pre-silicon stage and try to generate the pattern to detect the fault. So this is one of the example where we call as a stacked fault. This is a very popular, meaning some of the net is connected to the ground or connected to the voltage rail, VDD, tie high or tie low. So if that can happen, then how our design or how our DFT architecture should help to detect this kind of fault? That is what we will develop, some kind of DFT architecture to detect this. Now, this is how we actually start our working. Okay, we now know the problem statement. Which one we have to solve it? The pre-silicon, the post-silicon manufacturing process problem statement we have now understand. Now, how do we want to handle it into our pre-silicon design during our DFT architecture? So in our pre-silicon design, as I already mentioned, we will have the scan input, we will have the input and we will have the output, and we will have the combinational logic and the sequential gate. So in that design, this is called as a pre-scan design, meaning we haven't done any kind of scan insertion yet. It's just a functional design with a gate level representation. So in that design, if any of the net is connected to the ground, we assume it. Ideally, in pre-silicon, it will not be connected. But since it can happen during the manufacturing process, we will assume that if it is connected to the ground, then how can I detect this problem? So we represented the post-silicon scenario into the pre-silicon phase to find a solution of this problem. So the solution will be something like this. This is called a scan chain insertion. Scan insertion. We have started our work. We will modify the design in such a way so that it doesn't break the functionality, but it can also be able to detect any kind of manufacturing process. The architecture that will help to us, and the industry actually has adopted this feature, they call this as the scan chain insertion, where they will actually pick up the non-scan flip-flop. This is the memory element I just mentioned, right? There will be some memory element, functional logic, but memory element. So we'll target the memory element flip-flop to convert it to one kind of special architecture. That one we call as the scan flip-flop. It will have some kind of marks at the front, and it will have some scan enable signal, which will choose between the functional data versus the scan input. You see, we have modified the design in such a way that the functionality is still be there, but we have the option to drive some kind of scan pattern to load into the flip-flop. And after modifying this flip-flop, we change every flip-flop of the design, and then we connect all the flip-flop in a chaining manner. That is what they call as a scan chain insertion, because they are connected in a serial chain. Now we have the flexibility. With this architecture, we will have the flexibility to drive scan data from here to load necessary control vector here into this flip-flop, because they are memory element, to control the functional logic, and then take out the response from here. So this phase is called the scan insertion. That is what you will be doing as a DFT engineer. Now, once I complete the scan insertion, how will be the scan testing protocol? Protocol means it has to follow some steps one by one to detect the fault. This is our problem statement, right? Where we want to do some detect. Then we have modified the design, change all the flip-flop with the scan flip-flop, and build the scan chain. So it will be connected in that way, one by one. We will have a separate scan in pin, separate scan out pin. So these are the functional pin. It is already there from the design spec, but these are the additional things that we have added. And this is our DFT scan protocol. This is how we do the testing. So the testing has two phases. One is the scan shift operation. One is the capture operation. For every pattern, every test pattern that the tool generate, you don't have to generate the pattern. The tool will generate. You just need to build this architecture. Then the rest of the thing the tool will take care. But how does the tool take care of it? It will actually follow this kind of protocol. First, it has to load some kind of scan data for each of the flip-flop connected to the chain. You see, this is the clock pulse it is actually giving to load this scan data. This is called scan data to each of the flip-flop part of the scan chain. And that is what they call as a shift operation, scan shift. Then after all the flip-flop is loaded with some specific value, this vector, this is called a test vector. Then they enter into the capture mode. Capture mode means it is go into the functional mode. Shift mode is the DFT mode. And capture mode is the functional mode. That means it will test this particular node with the specific vector that has been put here. So it will capture the response of this fault circuitry, and then it will capture it into a flip-flop. Then it will just unload whatever response it has captured into this flip-flop. It will unload it into this primary output. So now if you consider about the tester perspective, when the chip manufactured, you can only see this primary input and the primary output. You cannot see whatever inside the chip. The tester will start to drive the vector from here. It will start to drive in that way. And it will measure the response of observed here. So the test vector automatically know what should be the observed value. But if the silicon has some kind of defect here, it will give you a opposite value. And the tester will show you that there is a miscompare between the expected value versus the silicon response. And the manufacturing defect has been detected. So that's the process actually we do for our scan testing. But we will have a more detail on discussion during our technical session or training session, that how the whole thing actually happens. So this is what actually I was talking about. After the chip has been manufactured, the test development is basically the test pattern that we generate. We deliver it to the test engineer. They actually develop some kind of program to drive it from the tester. So the tester will drive all the test vector to the chip, and it will collect the response from the output. And at the same time, the tester already know what is the expected response. It is already been written into the test vector. So the tester will do some kind of compare here. What is the response coming from the chip and what is the expected response? If the response is matching, then it's a good unit. If the response is not matching, it's a bad unit. This is how the tester will react. Pass, fail, pass, fail. This tester can only flag the pass, fail. And this is how we segregate the chip from the good to bad. Okay. I think just move on to some more information regarding the semiconductor industry overview. As I have already mentioned that the chip design process is a very complicated process and there are a lot of team needed for this one. Front end, back end, I have already done it. So whatever semiconductor companies you know or you will be knowing about when you jump into the industry, a lot of companies doing different kind of activity. So we'll have some kind of design provider, IP design provider like ARM, Synopsys, Cadence, a lot of company. They actually build internal IP and then they provide this IP to the big SoC design team. Then we have the EDA software team, Synopsys, Siemens, Cadence. There are many of the companies there. They have different tools. And also these are the IC design. You have already known the NVIDIA, Broadcom, AMD, Marvell, Qualcomm. These are very popular companies. They don't have any manufacturing. We have two types of company. One is the product based. One is product and foundry based. That means they have their own foundry. Like you see, IDM. IDM means integrated device manufacturer. Intel has both the product team and Intel has its own manufacturing team. So they build their product and manufacture it in their own foundry. Samsung has also this kind of opportunities. Infineon, they have own design team, they have own fabrication team. But if you talk about the AMD, talk about Marvell, Qualcomm, they don't have any foundry. They just do the design. After the design, they will send their design either TSMC or Samsung or UMC. These are the foundry. They provide the foundry. So they send their design here to manufacture. So we have two types of design. One is the product-based company. One is the product and manufacturing. They can do. These are called IDM companies. So these are a list of many companies actually, but overall in summary, you can classify them in two categories. One, they have just only do the design, but they fabricate it in a fabrication who have the provider who is actually providing the technology. But there could be another company who can build their own product, fabricate their own foundry. And this is the foundry roadmap. Those who are leading foundry provider like Intel, Samsung, TSMC, these are three companies leading manufacturing process. So they actually provide the technology node to all the product companies so that they can design in that technology node. So this is information until 2020, where you can see Intel can achieve 7 nanometer EUV, extreme ultraviolet technology to lithography technology to manufacturing the process. But in now it is 2025. So they have already been started to working on the 18 angstrom process, and you will be seeing a new product from Intel, codename Panther Lake, is coming from the mid of this year. That will be using the 18 angstrom technology node. It's a very advanced node. Samsung, they have also have the 3 nanometer. TSMC, they have around 3 nanometer, 4 nanometer. They have a lot of mature technology. Okay, I think this is my last slide where I will be highlighting some of the, as I have already discussed, few of the topics, but this is a one-place slide where you can see that what are the key responsibility of a DFT engineer? What are the key responsibility? If I want to summarize it, you have to collaborate with the cross-functional team, meaning you have to work with the physical design team, you have to work with the post-silicon team. You may need to work with the functional verification RTL team to establish a testability goals and requirement. Develop and implementing DFT methodology and test strategy. You have to do it as an engineer. Then you have to designing and integrating testability feature into the product architecture, create and analyzing the test structure and test patterns, ensuring the use of DFT standard and best practice. All those things, how the DFT can help to make sure the design can improve. So that's why they mentioned that a strong focus on testability from the early stage of design allows the efficient debugging, repair, and maintenance, resulting in a high quality end product. So you will be a part of engineer to make sure a high quality product to deliver to the customer. So you have a direct impact on a manufacturing cost or the revenue of the company. So what is the scope of this career in the industry? The DFT engineer has a very, very exciting role, because now whatever design is coming, without DFT, no design will be fabricated. So DFT engineer role is a very high demanding role. And is salary comparative to other engineers, you can expect more, because not many people is actually doing. So this field is still growing, and if you can enter right now, you will have a very good future or very good salaries in future. Within 2-3 years, you can jump into a very good company, and then you can hike your salaries. So this is just an example in India where you can expect this much of salary range if you have experience 0 to 2 years, around 4 lakh per year. So now